All right, welcome everybody. Is everyone having a good fest so far? Pretty good? Still just day one? Cool. All right, before we begin, I want you guys to really just imagine developing a game or a vertical slice for a game where the people that are playing the game or interfacing with the game are constantly moving around the room, forcibly. There's also up to 16 of them in the room. And you also have to track upwards of 600 controllers at the same time. Why would you do something as crazy as that? Well, because at Universal Studios Orlando, that was some of the demands that we had to meet to develop Illumination's VillainCon Minion Blast, which is an amazing attraction in Universal Orlando, pretty much 10, 15 minutes away. So this is the first time that we're able to really deep dive into the development and how we used Unreal to help bring a fully immersive real-time attraction to life. So a few of the things we're gonna be talking about, what is it? We're gonna dive into how we design the theme park, how do we design an attraction, and how is it engineered, and how that's a lot different than a traditional game. And then of course, how we used Unreal. We were one of the first, if not the first, public-facing Unreal 5 products ever, which makes it even more scary. So just a little bit intros of who we are. My name is Tony Mecca. I'm a senior creative technologist at Universal Creative. At the time of the attraction, I was the animation director and real-time media director.
Hi, my name is Nick Sofa. I'm currently a senior technical designer at Universal Studios Creative, and at the time of the attraction, I was Unreal Engine programmer, just generalist. Yep.
Yeah. Hi, everybody. I'm Jason Weeks. I'm a senior director, software architect for Universal Creative. So we look at how we put all the software together, architect it, the software stack from end to end. So I've worked on that for VillainCon.
Cool. And these three nerds are about to dive into the making of this attraction. So first thing we're going to do is give you guys a little video showcasing what the attraction is.
Very good.
And that was just a little taste of the immense amount of fun that you can have at the Orlando Park, just down the road. So with looking into and designing a ride from the ground up at Universal Creative, we really wanted to focus on what kind of experience we want the guests to have. And that always starts with the story and what kind of story we want to tell with our amusement parks. And we knew, working with our partners at Illumination, that we wanted to expand the story of the most recent Minions movie at the time, back in 2015. And the scene where all of the Minions go to VillainCon. They go see all the extravagant tech that the villains are making and see all the cool bad guys. And we wanted to bring that to life in one of our parks. So we knew we had to bring that scene from the 1960s up to current day and have it be a setting within Universal Studios Florida. And since the original VillainCon scene was set in Orlando, there was kind of a perfect match to have it in our park. We also want to think about what sort of role the guest is playing in any of our rides, whether they're a big bad villain or someone just attending a conference. We need to kind of flesh that out and have that be a part of the ride's design. So what we have is the remaining members of the Vicious Six kind of showing a recruitment video to the guests in the queue to be like, hey, be a big bad villain, come work for us, and you might get rich and famous one day. So that's sort of the guest's primer to getting onto the ride. Along with working with Illumination and Entertainment, we have a lot of different project teams that work to build various attractions throughout Universal. And a lot of different requirements that all of them have to set to make a nice attraction, a nice ride for the guests. We have various marketing and retail teams, down to construction teams if the building or the ride needs any sort of maintenance or upkeep. Health and safety teams, not only for our team members working on the ride at the time, but then guests once the ride opens and guests are actively riding it. The operations teams that manage everything after the ride is open. Also down to like what plants are planted outside of the building and making sure we know who's watering those. So spinning a lot of plates, and just a huge shout out to all the great team members that we get to work with on a daily basis. A huge push at Universal Studios is creating unique experiences at our parks and making sure that there is an experience that is nothing like nothing else in the world. And having the design of the ride track is one of those big innovations that we had created for this ride and wanted this to be part of the uniqueness. Instead of a regular ride vehicle that you have a couple, 10 or so people get on, sit down, have a restraint over them, and then they get sent off in a burst. This one has what we call an omni mover, which is like a big conveyor belt, sort of, that guests will stand on and be moved through the ride at a singular pace. So in having that design of a constant flow of guests, we have to design our media to be not only interactive, but also seamless and running for over 12 hours with up to a dozen or 16 dozen-ish, whatever, people shooting at these screens at the same time. So having to design other rides, there's points where, or even video games, you have a loading screen, or you have some points where you can reset everything. But with this constant stream of guests, we have to think about where we can kind of fit in those reset points and make it look natural. So a guest doesn't come into a scene and everything's already exploded from the 10 people in front of me, and then I don't get to play, you know? Another point of not a challenge that we had to overcome were the amount and design of the screens that are on the in the track as well. These giant LED walls and projectors that are bigger than this screen you see here. Anywhere from 1 to 5 screens in a specific scene that are all interconnected. And then also the non-linear like curvature of some of the screens where a screen would be 10 feet flat and then have a bend in the end. So you had to design the media to look right in this weird sort of camera angle on this flat wall. Optimization was also immensely important. We'll get into that a little later with the engineering side, but with the flip side of that, we were able to use insanely powerful hardware and not really have to worry about what a specific console might be able to handle or what the average graphics card that a PC user is using. We were just able to buy the latest and greatest and throw whatever we wanted at it, kind of. Yeah, so that was another big portion of designing this ride. So at Universal Studios, we also want to design rides and experiences for guests that just ride once and they go about their day and go on to the next ride. But also keep in mind guests who want to have repeat rides or annual guest pass holders that will come ride this ride a dozen times in a month. They're starting here with the mobile app that we keep as like a sort of mini app inside of the Universal Studios Florida app that would track any sort of player data and collectibles or achievements that you would get on the ride and out in the land as well. And then those would unlock customizable options for the player to change some of their aesthetics on the ride, like the blaster reticle color or shape or various different upgrades that you're able to get from ride to ride and So you'll have a unique experience every time you come back. So you would very easily take your phone and tap it to the blaster as soon as you get to the front of the ride, and be able to apply any of those upgrades that you would get. So you'd have a new, unique experience than the person standing next to you. And then at the very end of the ride, the blaster seamlessly transfers all of that data to our backend and updates it on your phone. So as soon as you're off the ride, you can take a look at your score compared to your friends next to you. And then apply any new upgrades or things that you got onto the next go-around. So what does the gameplay loop actually look like? We're talking a lot about screens and conveyor belts and guns and blasters. Not guns, blasters, so sorry. So what you see here that you also saw in the video, the screen ratio is a little different, but this is the first scene that you see when you get onto the ride. And we wanted to treat this as sort of a sandbox tutorial for guests. Because we know not all guests are gamers. They've maybe never played a video game in their life. So we wanted everybody to get up to a certain baseline understanding of the gameplay loop. So what happens when I blast a minion or a red box or a gold coin, and understanding what is showing the guests that they're having an influence on the game and doing what they're supposed to be doing, right? So we have a little example of the blaster here with the primary fire is what you see mostly in the scene with the different elements affecting different things in like the conveyor belt. If you hit it with electricity, it'll go faster and zoom some of the boxes off. Or you hit a red box with fire, it'll explode, that sort of thing. And then the secondary trigger on the blaster has a launcher that is all like very iconic little Easter eggs from the movies, like a banana blaster or a fart bomb that makes the minions laugh, that sort of thing. And finally, we have ultimates, where if you've scored enough on the ride, you have this big bombastic moment of a few seconds of like being supercharged and super powerful. So you rack up a ton of points. And then all of these are customizable, either before the ride or mid-ride, if you were to shoot, say, the red box with fire there. And the launchers and ultimates you can gain mid-ride if you defeat some of the bosses, and really try to get other guests to see, oh wow, how'd you unlock that? We want guests to want to try to sink their teeth into some of the gameplay things that we're doing here. And then after this first intro scene, we have one of the Vicious Six members in each of their little domains as sort of a boss that has their own patterns, their own weaknesses, and things that you would try to find out on multiple playthroughs that you would blast and like unlock new launchers. So yeah, that's mainly the gameplay design for VillainCon. I'll hand it over to Jason here to talk more about the engineering.
All right. You're going to be the demo.
Oh yeah.
Hello, everybody. All right. Well, let me just first say that this engineering task was a technical feat, right? I want to thank the teams that worked on this, because understanding the magic that happens behind the technical is really, it's beautiful. And it's something I appreciate. And a lot of people don't get to see what happens behind the scenes. But just think at it holistically on what this is. This is this blaster. There's 600 of them, always being tracked. There's 100 of them always being rotated in a queue for the guests to have that continuous flow of people. And then on the scenes, we're actively tracking 500 of them. We're getting the telemetry, we're getting the data, we're downloading visuals, audios, sounds, everything to the blaster in real time. So you think about that, we have a blaster going through 500 of them, all on the same network. And we're also going from the same game, just in different levels, right? So we're propagating 500 people through the same game. And these games are vertical slices. So they basically repeat the same thing over and over again, the boss loops, and they're interactive for each of the scenes. And then whatever the player does carries on to the next scene. We push it forward, the payload. And that continues on until we get to the end. So we have that persistence of scene to scene. And then also, on top of that complexity, we have a mobile app. We always try to push even further. So we have the mobile app where we can tap in when we first come into the gun itself. There's an FC here. We tap that in, has all of our previous times we played, all of our achievements, all of our perks, all of our new weapons that we can do, or even our seasonals. We have like seasons. Yeah. Every month we have a special weapon that spawns in the game if you want to play it with your ultimate. Start thinking about dynamic content and that idea. We did it all in this. And in the end of it, it was a lot of learning, a lot of bottlenecks, but basically it was a technical feat that we haven't done before, at least in our domain. It was something to be proud of. So anyways, onward to the next slide. All right, so minions being minions, they want to destroy everything. That's one thing that I really enjoy about this project because I get to work with minions, and minions are mischievous, and they just destroy everything. So we wanted to make sure we destroy everything in all the levels. So in the very beginning, we started using chaos physics. Well, that worked fine in the very beginning. When we started to scale it with a lot of players, that didn't work so much. And we worked with our great partners at Epic to understand why chaos wouldn't work. We did custom engines. We came to the point that the collections weren't reversible. We couldn't get away from certain hitches inside of it because it would cause an architecture change in how chaos works at that time. This is 5.1. So we ended up pivoting to old school techniques. We did pre-baked destructions. We went to Houdini or whatever DCC we had and pre-baked it, and then we brought it in that way. That way we could scale and get rid of all those destruction hitches that we were seeing. The problem is, in typical legacy, doing those kind of workflows, you have artifacts. Now you have a skeleton joint to all the different pieces that you want to break up. You have to manage those pieces. Those are all, it has a cost to it, right? So even just the visual fidelity, if you break something and the vertex is shared across the joints, you'll get a screen stretch, right? Everybody knows what that looks like. It's horrible. We don't want that. So we have to go back and redo all the models to do that. So we were able to gain a significant amount of performance by going back to old school methods. But we weren't there yet. The next thing we had to do was object pooling. Because in the scene itself, you think about it, we have all these players. I think our scene 2, we can have the 40 players at once in that scene. And they're on the travelator, so a moving walkway, playing the whole time. And they're just sitting there spamming that fire button, projectile, 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 explosion, explosion, collectible, collectible. All these things are being spawned. So what's a big cost that we have? It's construction and deconstruction of all the actors, right? That is a huge cost for our frame rate, and that's something we had to get rid of. And because our game never reset, there was no opportunity to do it. So if we started playing with the garbage collection, we could sit there and change the frequency, we could change the collection size, we could do all that fancy stuff. And then there's always a point that we had to dump the garbage, and whoever was on the tracks at that point, all the reticles would freeze at the same time. We don't want that. So we had to think very creatively about it. So we created object pooling. So we redid the whole architecture inside the engine to support object pooling. So every time we had an asset, we reused it. We just changed the state. So for example, the blasters were object pooled. Every time we'd sit there, we have maybe 40 blasters in a scene, and we'd sit there and move the player state into those blasters, and they would keep moving forward as it went out. So those kind of techniques really put us over the edge for optimizations. So I know we spent a lot of time on doing these dump hitches. That was pretty constant. I think you guys all know about that. And then the last thing we wanted to do, we still weren't getting there. We were finally getting our CPU bound, but our GPU and our fidelity, we were not getting it because we're pushing, 20 million pixels on one of the LED walls. That's a lot of pixels to render, and we're trying to keep 60 FPS. So the problem with that is, well, how about we use TSR, temporal super resolution, from the engine? The idea was like, hey, maybe we could downsize it 50% and then up-res it with TSR, and that would get our graphics up higher. Well, that's what we did. Right, I think we were able to do a 65%. We were able to do downsize 65% and up-res it to 100%. So that's a good technology. But there's some artifacts, and these are the ones that get you in the end. We got a huge a boost in performance, but then we started seeing artifacts with TSR. So TSR is interesting, and Tony will probably talk more about this. On LED wall, the pixel pitch and all the LED layout for the pixels themselves, they're too far apart, right? So whenever we have objects move across the screen, we start seeing a lot of ghosting. We start seeing a lot of ghosting from the previous frames because TSR takes the previous frames and uses the velocities to go to the next frames. We started seeing a lot of blurring across the screen. So we had to work with Epic quite a bit. And this is something that's great having great partners like Epic. They came on site with the engineering team. We went through on site all the problems, came up with custom shaders, the way we could take materials and move it across a conveyor belt and use TSR on it, how we had to make special colliders to block shadows, and it worked well, except for one thing. One thing is the render layer. So the reticle itself. The reticle itself was always a problem because it was above the TSR level. And that causes a problem because of aliasing. Well, you have all these reticles, everything's beautiful, but you have this really jagged edged reticle. That problem was a tough one because it wasn't supported. But we were able to work with Epic and CVARs, everybody's favorite word, CVARs, to find out what the right combination was to make it look good. Now, that is another whole topic we get into, but I know I'll spare you the pain. But CVARs, there's lots of things you can do with CVARs as long as you understand how to use them and where to get information from. That's something that Epic can help with a lot. So that's where they came to us, like we need to set this setting, and do it real time. So that really made a huge improvement on our optimization. We went from really low frame rate to 60 FPS pretty much with these types of huge vertical shifts. All right, so this was actually fun because I like networking quite a bit. When you look at all the telemetry and all the data going in and out of the blaster, you think about just the structure of the network you need to have designed for that, for all the different servers to communicate. How do you orchestrate that? Because the bandwidth is a problem, and latency is a problem. We don't want to have a guest moving the blaster back and forth, and it lags across the screen. It doesn't feel good. If it doesn't feel good, no one's going to enjoy it. So we had to set to be very strategic on our network buffer because if we slam 500 to 600 blasters on that network, it gets queued up and the buffer would overrun and we just start getting hitches all the time, right? So sure, we created a new buffer. We used a lot of TQs for all the inbound, all the different types of data packets. And so we can have that offload because you can save a buffer frame by doing stuff like that, right? So we did that. Still wasn't enough yet. We were still slamming so much data into our servers because every server is getting all the telemetry. It's like, okay, well, we just need to strategically, physically separate them with VLANs. Great. Didn't work enough. We need to do something else. So one of the cool things we didn't really talk about too much is a digital twin. So we actually this is actually a digital twin of the attraction inside of Unreal, right? So we know spatially where you're at with the blaster in the real world and in the virtual world. So we set up a system, a geofencing. We just started creating volumes inside the engine from scene to scene to scene. We knew exactly where the blaster was, so we only need to send all the packets that were in that coordinate system to that server. So we didn't have to send to all the servers. So that really solved a big problem we had for network flow. And the other thing was, typically in multiplayer games, because this is what it is, a multiplayer game, you have a dedicated server. Well, dedicated server wouldn't typically take all this inflow and spread it out, but the dedicated server is getting slammed too. So we needed a way to figure it out. So it's more of a peer-to-peer network, the way we started doing it. We pass information forward. It all starts in scene 0, right, and passes it forward. And as we go through the cycling of the scene, we would hand it off the player data to the next one. And then before we would exit to the last scene, we'd send it up to the cloud. All right, so the cloud itself, the app, everything in sync with each other and real time. And then as soon as the guest gets off, they want to see the scoreboard and see in their app what they did, right? So that's what the mobile app did for us, but it was a pain point because in the very end was when mobile came on. We had to do everything else first, the game design. We put the hooks in. We did, site unit testing for mobile, but we started actually integrating it. There's a lot of fun segregating NOC swipe zones to where they would start doing the payload. We had to do a lot of fencing zones to move that data back and forth. So it in itself was an engineering feat to orchestrate all that data and all those transport layers. All right, well, I will stop boring you with all the technical and I'll hand it over to the fun, Tony.
All right, the fun, I guess. How we used Unreal. So for the front end, we did a tremendous amount of work on art and animation to match what was traditionally viewed up until this point by most people in feature film, right? Illumination is very, very, very protective, as they should be, of their Despicable Me franchises, their Minion franchises, because they look fantastic. They are world-class visuals. So these were some pieces of concept art that I did find early on that were done years before we went to final, and it was really cool to see how close we actually got between the concept art and the actual final that we were. These, I think, were a little bit earlier, where these were just kind of like the chicken scratch drawings. It's a little blown out on there, but of where we went from the initial concepts to how we actually realized it. So the challenge is on the actual art side. How can we get something looking this good? Well, the first thing was bringing on our amazing animation team, our amazing effects team. We didn't have to build it for a console, right? We're not saying this has to run on PS5, this has to run on an Xbox, or even do what you would call a traditional PC launch, which is you want it to run on a very wide range of PCs. There was a very, very specific time, this is burned into my memory, where someone came in and they said, "Tony, this scene is using 37 gigs of video RAM." And my response was, hell yeah. I was like, "Are we still running at 60 FPS? They're like, "Kind of." I was like, hell yeah.
It's cooking the MDF.
Yeah, exactly. Yeah. So really, it was challenging to design a game that has to have a constant scene loop that runs for 20 hours, sometimes up to 24 hours a day, if they don't reboot the attraction, which doesn't really happen a lot. So creating animation trees and animation loops that literally have to go 20 hours a day and not destroy and not have garbage collection, not pick something up or have something fall off, and have all of these extremely complex levels of animation diagrams and animation trees that will allow us to say, if something blew this up, if the ice did this, if the fire hit this, blow this up this way, move into here. If that combination of craziness occurred, how can we remove a minion from being stuck elegantly and not look like it's, freaking out a little bit or doing some of that stuff, and despawn him and respawn him back to where he needs to be? Because traditionally, there's a lot of garbage collection that goes on in games. You go to the next level, you turn the console off, you turn it back on again, and our stuff has to be in a complete constant scene loop. The graphics hardware, this is something that I love diving into. We found that, and I'm sure a lot of the developers, I'm sure there's a lot of you in this room that are deving on, the PlayStations and the Xboxes and the Switches. Unreal and a lot of software out there does not care how many cores you have, right? In terms of when you break like 16. So I remember the initial servers we had just to test some things out, there were like 128 cores, and we would see core 0 through 15 pegged at like 100% to 80%, and then the rest of them sitting idle. So we learned very, very quickly that Unreal is going to be optimized for the amount of threads that are in the latest video game consoles. So we got a massive performance boost by, instead of going for more cores, obviously going for less cores, higher clock speeds, which brought in different challenges because we can't just put gaming PCs in these things. These need to run 20 hours a day. They have to be servers. So we designed kind of hybrid HEDT server systems. And then the graphics hardware. I am a graphics card nerd. If it was up to me, I would have put the latest graphics card in these things 24 hours before we opened, which we pretty much did. You have to use Pro cards because Pro cards are designed for servers, and Pro cards are designed to be robust enough to run for that amount of time. There's other parts where they're picked from the center of the wafer and all that kind of other stuff, but I'm gonna dispel one of the biggest myths in the world right now. And I can say this for entire certainty. How many of you guys have dealt with like G-forces before, Quadros, like the differences? You guys know with like Quadros, you have to go to like get the Pro drivers, and G-forces, right? Show of hand. No. The Quadro and, well, now they're just called the RTX line of Pro cards, will work with game-ready drivers. You can install the latest game-ready drivers, and it will enable all of the Pro features and give you all of the latest features of the latest game-ready optimizations for Unreal, any of the ray tracing, path tracing, any of the stuff that's in there. It's just not certified for Pro use, which is fine for our use cases. So I want to dispel that myth right away. One, we had to kind of take things to feature level animation. For those of you that have worked in feature film and in games, or both for that matter, it's very different in the pipeline. Okay, a lot of times in feature film, it's like, I don't care, put 55, 4K textures on the eyeball. So to match that fidelity, there was a lot of care put into what I called, I don't care, just go chugga go. And there was a concern of mine where I said, okay, well, if we were going to say, let's create the facial rigs and the shaders and do all the things that you would traditionally do, can Unreal handle it? Can it actually do it? I'm not deving for the PlayStations. I'm not deving for the consoles. If I have to use up, like I said, all the video RAM that they'll give me at that time, the cards in there, 48 gig cards dispersed among multiple servers, will Unreal actually just do it? Not say, are you sure you want to do this? Because it's probably not going to have a high frame rate for a mid-level PC or even, a high-level PC or a PS5 Pro. And the answer is yes, it did. The entirety of this attraction was hand-keyed. There was no motion capture. We had over 1,000 hand-painted textures, all running at between 4 and 8K, because of the fact that we were running on massive resolutions with LED walls, projectors, massive TV screens, and everyone needs to remember that it's not the environment that's being built just virtually. The Unreal scene, like Jason was saying before, is completely aware, and the level is built from the back of the real wall of the attraction into the actual gameplay level. So the Unreal file just looks at the screen or the projector or whatever that is, just as a window. That's it. Like, it is looking into that world. And I even think some of the levels inside of the Unreal files had some of the rafters and the lights in it and stuff because we wanted to get collision on that. Make sure that it's, content aware. So building something like this is not at all like you would traditionally make a level. And of course, like, we mentioned before, your people are moving. So having okay, are your reticles aligned correctly? Does it feel like when you shoot a shot from this angle when you enter, when you shoot a shot from this angle, does that look like it's going into the virtual window and traveling accordingly as well? So we had 10, bosses, 6 boss level vehicles, all sorts of stuff that we kind of took from the feature film and our partners at Illumination and either adjusted them or reconstructed them to just work in real time. There was a lot of optimizations that needed to be done, a lot of obvious things. When you get an asset from feature film, you might have an eyeball with 211 draw calls in it. I think that was the record. But like an eyeball and like 40 UV sets for like an arm, which is fine. So some of the stuff did need to be rebuilt, which is fine to get it just into the level of not insanity. But it was incredible how well even the first iteration of UE5 was able to get these feature level assets running if you had the hardware to do it. So with the animation, we did use not what you would traditionally do in a game. Tons of blend shapes on the faces, tons of high resolution textures, shaders, different types of blurring effects. The animation system itself is something I would say do not do this if you are developing cartoony level animation for PC release, for Xbox, for PlayStation, for Switch release, especially with the more stylized things because of the fact that we needed to get the Minion's mouth moving like from here to the big expressions that they make to how quickly they can move to their eyeballs doing certain things. There's a lot of tricks that go into pre-rendered content with your traditional, Maya workflow into feature film that aren't necessarily good practices for regular game development. But for us, we did them because we wanted to match the highest fidelity possible. And did the engine do it? Yep, sure did. We were like, we're gonna put 7,000 to 10,000 blend shapes on this character. Did the frame rate go down? Sure did. But did it work? Yep. And so it's just a testament to how well Unreal was able to just say, all right, we're gonna go ahead and just take it and we're gonna just have it work. So hopefully in a few years, once we see the graphics hardware and CPU power get better and faster and stronger, we'll be able to just not have to worry about some of this stuff, which is really cool. We had an incredible animation team, over 900 unique hand-keyed animations. Everything was hand-keyed, no motion capture, no any kind of performance capture or anything like that. Button, okay. when Jason said earlier we had to go old school on the destruction and Houdini and stuff. No, we went even older school. This is Tony hand draw joints school inside of how we wanted things to kind of collapse in itself. One of the scenes that was really cool, we had the orca from Jaws we put in there as a little kind of Easter egg, and because of how many people were shooting at it from very specific directions, we literally had to art direct the physics behind it, because people entering would shoot at the left side, people exiting would be shooting at the right. There would be a collectible there or some sort of type of attention being drawn to a specific part of what you wanted to shoot at and what you wanted to blow up. So based on gameplay, we couldn't just say, just blow it up, just do physics, do whatever. We had to literally adjust and art direct how things were pieced together based on having 16, 20, 30 people in a scene shooting at it at once. And a lot of these were reconstructed multiple times based on that guest feedback or what we saw, well, not really guest feedback yet because the attraction wasn't open, based on team member feedback, based on us testing it, which is very cool. One of the very, very fun things about traditionally Illumination franchises is they have incredible animation with very stylized, you can call them cartoony characters, but the effects are all like real world. Right? They're not cel shaded or anything like that. They're done in a very realistic style. So being able to kind of really push Unreal on that side too, and see how it actually interacted with the cartooniness of the characters was a lot of fun too. And again, it worked. There was a lot of warnings, like, are you really sure you want to be doing it this way? And we said, am I still at, Jason, are we still at 60? And he would say, no. And I would say, but look at how cool this looks. And he's like, but we're not at 60. And I'm like, let's see if we can do it. And there was a lot of back and forth to get it kind of pushing to that very, very edge, because I wanted to max out what Unreal and this hardware could do. One of the biggest challenges, and this is kind of going through how we had to like block this out, was our finale scene. And the finale scene kind of represents, like a portal within a portal within a portal, because what it's supposed to do is essentially at the very, very end, there's a giant hole blasted through the attraction itself. It was 3 massive projectors, the biggest scene in the attraction, and you're to fight the final members of the Vicious Six. But when you're dealing with an Omni Mover, you can't go through up to 4 boss fights and still keep people moving and get your attraction holding capacity moving the entire time. So one of the things that we had to develop was a way to say, okay, how can we have people be in this scene, have a meaningful boss engagement, get all the collectibles they want, do what they need to do with those particular bosses, but still get the amount of people through that we needed to. So we created a full animation looping kind of staggered system where no matter where you come in at or no matter where you leave, you're guaranteed at least 2 boss sequences. And that was extremely challenging in terms of game design and animation, because we can't plan when someone's going to start the game. We can't plan when someone is going to say, I'm starting the level, let's start a cinematic and move to this and do this, and kind of, regular kind of game design development. We had to say, what happens if someone comes in halfway through this? What happens if someone comes in here? Because the Omni Mover belt is just going to keep moving people at the same rate over and over and over again. So what we ended up doing is creating a quad scene loop, and you can see a little bit of the kind of animation graph there of very, very, very meticulously planning this out, even just in blocking, and tested it out to see how we can guarantee everyone is at least working with at least 2 different bosses. So this is one of the big randomizations inside of the attraction, and a lot of people at the very end will argue, I saw this boss, I saw Scarlet, I saw this other character, right? And it is actually different between characters. But that was a lot of fun. It was very challenging, but there was so many times in this attraction where we're like, man, this is frustrating. How do we get this to work? And then we kind of like thought about it for a second and go, nobody else has these problems, because nobody else is going to do anything like this, because this is a one-off bespoke thing that only needs to be developed for an attraction at Universal. And I think we got a big boost in excitement every single time. We would just be like, oh my God, why are we doing this? This is the amount of times we would ask Epic, we're like, we need it to do this. And they're like, why?
I think Epic got tired of us calling.
Yeah, why would you ever do that? That's ridiculous. We're like, well, because it's an attraction. It's a one-of-a-kind thing. But again, that's a testament to our partnership with Epic, and them being extremely helpful and extremely interested in working on something like this, which was very, very cool. cool because something like this might not ever be built again, right? It's a very bespoke one-off thing. So yeah, that's a kind of a little insight into how to make something crazy that is not necessarily supposed to be done anywhere else, and how unreal and hopefully you guys found some interest in why we had to do things a specific way, and first of its kind for a really big deep dive into things you have to think about when designing for a major attraction at a major theme park. So I want to thank you guys for coming. Obviously, we want to thank all of our partners. We want to thank Epic, Illumination for helping us with this. But I wanted to go ahead and open it up for a Q&A if anyone has any questions for us.